Okay. We so far we have seen basics of Python, how to write basic code in Python. We have seen threads and process, and most of the times our server programs will run in threads. Any request that comes to the server will spawn a new thread and run the application logic in that thread. But that is all abstracted away by the frameworks that we use. So, so for us to experiment with the REST APIs, we already know that REST has equivalents for CRUD applications. So a brief introduction of CRUD and verbs like get, post, put, delete, options, head. All these have been discussed already. So today we are going to implement these verbs in a simple framework called FastAPI. So let's try to use that FastAPI. Let me install FastAPI. So this is a simple framework. So compared to Django, FastAPI is a lightweight API which only gives API functionality, whereas Django is a full stack framework. It allows us to have templates, rendering, UI logic, and database integration and everything. FastAPI only gives the bare minimum functionality required for implementing REST APIs. It doesn't give any ORMs like Django does. So first let's explore FastAPI, then we will dig into Django and implement full stack applications on Django. For now, I have installed FastAPI here. Let's create a new program called server.py. So if I installed it correctly, FastAPI should come in the terminal. So it's use FastAPI. Let's run this. So all the dependent packages, it did not install if I used just the FastAPI. If I use standard, it's going to install all dependencies. It depends on the package which we are using. Okay, FastAPI is now available as a command line utility. So now let's try creating a new program. So from FastAPI, import FastAPI. Just like Express, we will just import FastAPI and we can initialize an application with FastAPI like this. And let's run this application. This just initialized an application. It doesn't serve any URLs or any requests as of now. Let's try running this server if it works. FastAPI run server.py. This is a production server. It runs in production mode. So we can reach to this server with 8000 port on the local host. Let me open a new tab and present. Local host 8000. So no APIs have been served so far. Its server is running. So also one more thing I get by default with FastAPI is the documentation for the APIs that we write. If you go to docs, all of the APIs that we write will come here. It's a UI for experimenting with the APIs without using the Postman. We can actually use from here itself. So we haven't written any APIs so far. That's why we are not seeing any APIs. Let's implement a new API, then we will get back to this. So as I'm now creating a new API, so I have run the application in a server production environment. Let's say if I do run means this is actually running in the production environment. So it doesn't automatically refresh the server or restart the server whenever I change the code. If I run it here and let's try creating a new handler for get. So how do I write a get function is through a hand annotation or decorator called get. So the path of that will be specified in here as an argument. And I'll have to write a definition of a function that does the health check. The decorators, we have already discussed about how these decorators work. And this is a built-in decorator that allows us to serve HTTP GET requests on this particular path. So whenever somebody requests /health path from the browser, we'll have to return something. So I'm giving some none here, nothing, empty. Let's try accessing the server, but it did not restart. So if you see here, the server did not restart. If I go access the server URL now, it doesn't have that because we haven't restarted the server. Not found. So it's a default error that is giving that the fast API is giving. It's not able to find that path because we haven't restarted after changing the code. Let's restart the server, or there is one better way to do it. If I'm in the development mode, I can run the dev server so that every time I change the code, it will automatically restart the server. Let's cancel this process. Let's run the fast API server in dev mode. We can run the dev server with dev like this. So now let's go back to the browser. Refresh. Error is null. Okay. Now I'm going to change the code to return something apart from error. This time I don't have to restart the server because I'm running a dev server, which automatically takes care of restarting the server whenever I change something. Let's change this thing to message. I'm up and running. If you see this is actually called JSON. We already had a brief introduction to JSON. This is actually going to be an object that's converted into JSON and sent into the browser. So if you see here, the server application has restarted. Let's try to go back to the browser and check the status. So message is coming and error is null. Okay. Now it's time to have some more advanced things. Now we have run it in a development environment. In production, how do we run this in production? There is a server called UVCon server, which we'll be discussing in some time. Let's have some APIs that are asynchronous. Let's say this is actually a synchronous process. If there is some operation that reads files or writes into some files, and we would have to do some complex operations. Let's say if a server is required to do some complex operations, it requires time, right? So for that, we will have to use asynchronous operations, just like in Express, we have async await. We also have the similar functionality in Python using async IO. Let's use those async IO functionality. And as I've mentioned earlier, so if not as a server like this, we can actually run this server directly, server.py directly. If I have some code, a metadata code, if I write here, just like we had earlier, if the name is equal to main, I can actually load a server component. Basically, what FastAPI terminal command is doing, what this is doing is it's starting a Unicorn server, UVCon server. UVCon is a package or a server, HTTP server implemented in Python. So same thing, we can import and use it directly. Instead of relying on FastAPI's CLI, we can import UVCon and start the server ourselves directly by executing server.py. Here UVCon dot run the application. This way, we don't have to use FastAPI utility or CLI. We can directly execute server.py. It will start the server. FastAPI import. Okay. It's unable to find the path. Let's not have this. We'll revisit this in some time. So now it's time to go back to the async IO. How do we handle, let's say I have a large program or complex set of instructions that takes time to calculate. How do I handle that kind of scenario? Let's simulate that scenario with sleep, time.sleep. So let's import time module. Let's implement a new handler called normal system sleep. Let's just sleep for 1 second here. Time.sleep. Return error as none. Let's handle this with app.get sleep system. Okay, this is normal way to sleep while accessing an API. Basically, this sleep I have introduced only to introduce a delay. Apart from this, we can also implement the same logic with an asynchronous mode. That is through declaring this function as asynchronous. System sleep, if I'm going here, instead of system sleep, if I do time.sleep here, basically what it does, so this actually uses a special library called async IO, which blocks the system from doing any other operation. If I try to access this API, let's just copy this get decorator to use async system. If I access this API now, this will sleep for 1 second. Let's add it. and all the threads will be blocked. If I am using asynchronous handler before, this will block all the system activity on this particular endpoint. If anybody accessing 100 times the same API will be waiting for the API to complete, for the first process to complete. So after the first process is completed, then the next thing will get served. It's like serializing the threads. So when we did not use threads, it was serializing every time, right? Every request was executing one by one. So that is what this will achieve. And if I do the same thing, just a little bit different, async, asynchronous IO. This time I'm going to do asynchronous IO. Instead of using time sleep, so because this is a system library, this will hold off the system's activity till all the asynchronous operations are completed. So instead of using this, if I do await and use async IO sleep, I have to import this async IO. This what it will do is it doesn't wait on the program or thread to complete before proceeding with the next request. So this thread spawns in a different, this function runs in a different thread, and all the new requests will be spawned independently with new threads. So this is a way to use asynchronous IO operations. Let's run the server. We cannot demonstrate multiple processes running in parallel right now with the browser. Just to know is enough here. So there is something called async IO, which we can use to have asynchronous threads running in the server. That's all we need to know about. So let's write one more handler that uses some dynamic utilities like date time and everything. Let's write an API, info API, app.get info. Let's write a function called info, return a dictionary. This dictionary is going to be serialized into a JSON object. So far we have been hard coding all the values. Now this time we are going to generate new values every time. So let's just say version as 0.1.0. Time, this time I'm going to calculate every time dynamic value. So there is a library called datetime in Python. This gives datetime in current date, import from datetime, import datetime. This is all, we are all using get APIs here. Similar to this, we can have post, put, delete, all that. We will be implementing it shortly. User, let's just say who is actually running this server. If I want to know, there is something called environment in Python. This is a package we should import. Import from OS, import environment. So all the variables set by the system in the current environment will be coming in the environment object. So what's the user that currently is running this server can be known from this. Let's try running this server. Let's run it as FastAPI dev server.py. Let's go to the browser. So we'll just access the API info. There is some error. Let's go back to the code and see what's the error. If you see the terminal, you can see the errors. Key error. So user variable is not found in the environment. That's the error. This is because we are using the Windows environment. Let's try using home instead of user. Sorry, home. Let's see if this is going to work. Let's try to access this separately out of this context, server context. Let's create, go into Python, import from OS, import ROM. If I just print and ROM, okay. Now I have home. Let's try. Home is also not found. So what is available? These are all the keys that are available in this Enron dictionary. Number of processors. If I'm executing the same program in Linux, it would work because home and user will be defined. But in Windows, we have to use something else. Home path. Let's use home path. Let's go back here. Okay, it's not going away. Let's run it again. I have to kill this process with task manager. Let me do that. Okay, just now kill the process again. Now I'm going to start the dev server. Let's go to the browser. Now it's loading info. And same thing, if I go to /docs, FastAPI defaultly gives all the experimental UI. So all this, I can actually request the API from here. If I execute, the response will come here. Similarly, if I do this will respond after 1 second, after sleeping for 1 second. And this one, this also does that, but it is going to halt the system for 1 second and then return. This one does asynchronous processing, doesn't wait for the request to complete before spawning a new request. And this one, info, I'm doing a get request right now. What it does when I click on execute is it's going to send this request. If I want to do it from the command line in a Linux terminal, I can copy this command and execute. It's going to do a get request on this endpoint /info endpoint. And the response I got is this JSON. So that's about dynamically generating content from the uh, backend. Now, what about accepting parameters from the URL? Like if we have seen, if you know, so there are some URLs like slash logs, let's say start date equals 2025 0 ampersand and date equals 2025 0303. So this kind of, these are all called URL parameters. How do I accept, like let's say based on this URL parameters, I want to dynamically generate content or a database query. If I have to see the logs of the last 3 days or last 2 days based on the start date and end date, how do I accept these parameters from the URL is something that we are going to let you know. Let's go back to our code. Let's write some handler called logs handler. Similar to this above thing, we are going to have this decorator for logs. This time we are going to accept two parameters, start time and end time. So those things will come as arguments to this function start. So one thing we have to note here, so in just like in TypeScript, we can define the data type. So basically the Python doesn't need to have data types declared by the program. I'll just kill this process 1 second. So Python a equals 5, 4, 4. This need not have any declaration about what's the type of a. So we can also define it and not define it. Both ways is allowed. So if I say a colon int 4, this is allowed. This is also allowed, but it's only a hint to the linting program. Linting means it's actually validating whether I'm writing correct code, syntax is correct, all data types are correct or not. ESLint is one such utility, but that will check while you are writing the code, it will check if you have written code correctly. So syntax errors and all will be handled. So we can actually give the hints to the linter so that it validates the code before I compile or execute. So that's, I'm going to use this syntax for hinting my linting program. So this start is going to be, this need not be required. We need not, it's not compulsory for the Python to have these annotations, but it doesn't harm adding it. So this start is going to be a datetime object. So FastAPI has a built-in functionality to convert strings into datetime objects. Based on the data that we send in the URL parameters, it will automatically convert into UTC datetime. So start is a datetime and end is also a datetime. These are the parameters that is passed from the URL parameters. And let's have one more thing called level. It's a string. A default one, I will default it to none. So return something, a list of objects. I'll just send the same data back. Start and level. So a trailing comma is not compulsory, but it's better to use a trailing comma. So what this does is whenever I access this URL with the URL parameters, it will read them and add it to this. If I have custom logic to database, do a query to database to retrieve logs in this time range, I can pass in these values. That way it's dynamically generated. The response is dynamically generated. So let's try accessing this API now with our browser. If I refresh this, this will automatically show us that API. Sorry, docs. I have to start the server. Just give me a minute. FastAPI dev server.py. Reload. If you see logs, it accepts three parameters. Two are compulsory, start and end, and level is string. So these two came compulsory because we haven't mentioned any defaults to these two arguments. If I go access this, I can do it like this: info/info start equal, sorry, question mark start equals 2025-0301 ampersand and equals 2025-0303 ampersand level info. If I do this, it's giving the same. Sorry, wait a second. It's actually going to the slash API because we have added a default handler for info logs. Sorry. This is going to info. Actually, I need to send it to logs. So now it gives the correct values that I passed here. So same thing I can achieve with this Swagger. This is called Swagger interface. This is a UI to experiment with the values. I can do that with 2025-0301 2025-03. Okay, that's fine. Now what if I give some wrong data? Something that is not possible. There is a validation by default with this interface. Let's use this here. Error. Input is too short. And whatever error happened in the backend, it's throwing to the UI. Let's go back to the server and see what's the error it's showing. But none. It's actually coming from the FastAPI. While passing it, it's getting into that error and throwing that back into the UI. But if we see the back, inspect and see, let's see, is it throwing the correct response code or not? If I go inspect this, let's see the network. Let's do another refresh. It's giving a 422 error. Unprocessable content. This is actually being thrown by the FastAPI while parsing these date strings. So by default, we have the functionality. We don't have to handle this error in the code. So FastAPI gives that functionality for us. And if I have to have some extra parameters or extra validations, I can add them. Let's add some custom validations to our code. That is through raising exceptions. We can raise exceptions. So let's just do a check if the start time and end time are correct or not. Let's say if start is greater than is end, we will raise an exception, raise HTTP exception. This HTTP exception comes from FastAPI. Let's import this HTTP exception from FastAPI. From FastAPI, import FastAPI, comma HTTP exception. This exception I'm going to raise here with a message, and status code I'm going to use as HTTP status. This HTTP status also is a library class which we can import with HTTP from HTTP. Import HTTP status, and this has a set of statuses, status codes, just like 404, 403, all that. It's a bad request. Bad request. Similar to this, we will have one more error condition. Let's say log levels. I will, or else if I just say if log level is not in info warning errors, raise another exception, HTTP exception with status code as HTTP status bad request. Let's say detail as invalid log level. So these are all standard parameters that HTTP exception handles. If you go to FastAPI documentation, you will find this information, how to use these exceptions and everything. And if, let's say, level equals warning, this I'm just raising an exception just to demonstrate the 404 error also. HTTP exception, status code 404. Let's do status not found. Okay. So there are three scenarios we are calling. We have to test if start and end date. If I give the same, it will give me a bad request. And let's have a detail here that says cannot have both start, must be before end. And another one, if I pass a wrong level, it will give an error. And if I pass warning as an info log level, it gives a not found error. Let's try this in the browser. Let's keep this to the side. And logs start date, I'll just give 2024-03-01 or 02. Same date I'm going to use in the end. And this should give me an exception. Detail start must be before end. It gave me 400 error, which means a bad request error. This is a bad request, 400. So if I try it here, execute, start must be before end. Error, bad request. Let's try using a level that is not in that critical value. Let's try this. I'll use a valid number here. Invalid log level. This is also a bad request. Let's try warning. Not found. 404. This is how we raise exceptions from the backend API. And what about now? We will look into post requests, which allow us to create new content in the DB or in the server. So I've seen last time that there is FastAPI, initializing FastAPI with this, just like Express. So we have annotations or these decorators, which will allow us to do get request or post request depending on the purpose we are using this API. So whenever this endpoint is called, this function gets called, and whatever this returns will go into the browser, the client response. So we have seen asynchronous handling of requests. Most of the times we won't be needing async unless we are doing some heavy lifting in the backend. So every time we use async, we should ideally be using async IO functions. If not, we should always try to do it this format. So that's about the get requests. We have seen parameters, URL parameters. The URL parameters are passed like, let's say, the request will come like this: http://localhost 3000 logs question mark. Each of the parameters, URL parameters, will come as a set. Start equals something 2020 50 ampersand means each and every parameter will be separated by an ampersand, and is 2025 304, and then ampersand. The URL and the parameters will be separated by the question mark, and then each of the parameters is separated by the ampersand. That's how we pass in URL parameters. This is the sample request format, get request, that will do it in the browser. So this is about get requests. So let's look into how the post requests are made. So similar to this get request annotation, we will have something called post, which I'll be using now. I'll create an endpoint. So let's say for recording new sales of an enterprise. So I'll just add something called app.post. The endpoint I'm going to use as sales. And let's define a function, new sale. So this has to accept an object. Basically, what data we accept in the JSON, like whenever I'm sending a post request, what will be there in the body is what we will use it here. So that we have to define as a parameter and has to be an object. So let's say there is a sale object, and in Python, we can also specify an optional parameter. What's the type of this parameter? Let's say if this is an integer, let's say a variable is an integer, x is an integer, then I can actually specify x colon int equals 5. This colon int is not compulsory, but it helps us understand the code better. So this is only a convention, not a compulsory requirement. So now I'm passing sale object, which is type sale, but I haven't defined this sale type yet. I have to define the class sale. So in order to use this sale, I have to define a class sale. I'm just going to do nothing here. This means a sale object, an empty object, no parameters, no attributes are there. But I actually need data to be passed from the body, request body, into this function. So I have to define the actual structure of this document. So in FastAPI, any object has to inherit from base model in order to be passed into the post request function. So this base model has to be imported from the FastAPI. FastAPI has a support library called Pydantic, which is by default installed along with the FastAPI. Let's use the Pydantic base model. From Pydantic import base model. So this base model is what we will be using as a parent class for the sale class. So inside the sale, I'm going to define some set of attributes that I'm going to pass through the request body. Let's say I have at what time the sale happened. This should be at date time. And this is one attribute. And I will have customer ID, which is a string. So this customer ID, I can actually use it, user field attribute. A field is also a data type that is defined in Pydantic. Let's have import a field also. This is similar to database field. So ultimately what we are going to do with this sale object is that we are going to store it in a database. So that field has to have set of rules or limitations, we can say. So what's the customer ID should have is, let's say, minimum length I should have as 2. So at least it should not be empty. That's what we are trying to impose these rules. But when we define these kind of rules, when it's parsing the data from the request that we post, if there is something wrong with the request, if the body does not match these criteria, it is going to throw an error that you have passed invalid data to the post request. That's the advantage of having pre-validations here. Okay, I have time, customer ID, and I will have one more thing, amount as an integer. That is also a field which is greater than 0. It's an integer. Price is float. Again, field greater than 0. We can pass price and amount as 0. And that's it. We only need this. So once we have the sale object passed into this, we need to store that somewhere in the DB. Let's say I will have store it in the database, and then return the response. When I pass a dictionary, it's going to convert that dictionary into JSON response, and then yeah, it passes on to the client. So now I'm defining one attribute called say ID. So 1, 2, 3, 4, or I'll just say put it as a string. So once we store it in DB, we will actually get an ID. That ID will be passed as the response object. And now, so once this data is stored in DB, and how do I get it? Is through get request. I'm going to define another get request for getting the sales objects. And this one I'm going to pass as ID as an argument, as a URL. Basically, what this defines is, so after sales, if there is a ID that is coming, it will be used as the parameter. So how do I read that parameter? Let's say this one, I will make it as get sale. So I'm going to pass that ID as a parameter here. That's actually going to be a string. And we can also specify what's the return type of this function. So like this. This is a new syntax. This is not all compulsory, but it's helpful to know what's the accepted parameters and what's the return value. This is a special syntax we haven't covered yet. But this is not compulsory. It only helps us understand the code better. So this time get the data from database. How to retrieve from MongoDB we will discuss in some time. Storing in DB and retrieving from DB, that we will cover in a later class. For now, let's say I have retrieved the data, something like s equals time is something like data. But now customer ID is a string, so it should be oh, this is dummy data. I'm sending it to the client. Amount this should be an integer. Minus this should be a floating point number. Okay, now we have the post request method and get request method. And this time after retrieving, I need to pass that, return that object from the DB. So I haven't retrieved from DB yet. I'm passing a dummy object here. Let's run the server and get it tested. FastAPI dev server.py. Let's go to the browser. Localhost 3000 docs. I think something is not. I think the port is 8000. So we have post request and get request. Let's do a post request now. So, but this thing you can actually do it with Postman also. So let's do it, try it out. And it's already defined a sample data for us. I'll just pass this information to the 400 is to the 0.50. This data, I'll leave it as it is. Execute, and it's successfully executed and given the response as ID 1234. If you go back to the server logs, you can see here the get request and post request came last. Post request went to the sales endpoint, as you can see here. So now let's do a retrieval of the data with the get request. Let's just do one simple validation. I'm going to pass in something like 1234. Let's see if the validation is working. So this is supposed to be a string. I'm passing it as an integer. Let's try it out. Unprocessable content. So response body is giving us input. It should be a valid string. So this validation is automatically happening with our field definitions that we have added. So that's a good sign. Let's do a retrieval of this ID. I'm going to use it as 1234. Execute, get request. We are getting this dummy data that we are passing from the data from the backend server. Now, the same thing can be extracted from MongoDB and fetched into the browser. And post request can similarly do store it in the DB. So we have actually made a basic interface that can store and retrieve information. That is basically create and read. So update and delete, similar to create and read, we can have update and delete operations as well. Let's go over simple form. Let's just give me 1 second. Okay, let's create a simple form then. So now we have seen how to do CRUD operations, see and read, create and read operations. Then let's implement a sample user interface to do that only the post request. So how do I actually use this in an actual application? That we will see now. So in order to build UI on top of these requests, we need to use HTML. So before we can use HTML, we need to handle or render the HTML from the server, right? So that we have seen in Express. Let's see how to render a HTML page from within this fast API. Let's create an API, just like previous post request. We are going to do post request. And I'm going to have a HTML file. Let's say where I'll create a new directory called static, which has all HTML code. This is all template code. So in proper frameworks, we will have templates in Django, in framework like Django. But here we have the flexibility to choose whichever folder we want to do. We want to use as templates folder. So all static resources I'm going to serve from the static directory. So this static directory, I'm going to create a sample HTML file. So I'll just create as HTML called index.html. For now, I'm just going to do hello world. Later, we will build a form that will do the post request to the APIs. So this static folder I need to serve from, but server doesn't know it has to serve this index.html whenever somebody accesses a page. It doesn't know. So we have to actually add that code to the server to be able to serve this. For that, we need to use something called FastAPI static files. From FastAPI, it gives a static files middleware from FastAPI dot static files import static files. This is a middleware that will be useful for serving static files from a specific directory. So after initializing the FastAPI, I will specify. So if there is a request that comes to an endpoint, static endpoint called slash static, and serve the files from the directory static. So whenever somebody accesses static slash index.html or just the static, it's going to look for a file within the static directory and serves that file as a response. Let's try running this from browser. Static still, or is mount? Sorry, this is not static. It's actually a mount. Mount means on this path serve the static files from this directory. Let's run this on the browser and check. So this time I'm going to access localhost 8000 slash static. And by default, when you access static, it's actually not running. We have to restart the server. Yes, yet 1 second. Okay, let's try accessing static index.html. Okay, now we have it. So hello world is coming. Now it's time for us to add some HTML form to it so that we can do a post request to the APIs. Let's add some code to this index.html. The first thing we need to do is define a form, or let's say I'll just define some sample HTML template. This is something like a survey form. Let's have something like a form. Basically, what we need is a form element, and the method should be post. These all will be covered when we are covering HTML basics. So this is how you define a simple form in HTML. So what on action specifies on submission of this form, what action needs to be performed is what action specifies, and the method in which the data has to be passed to the server is specified in this method parameter or attribute. So action has to actually go into something like what we defined in here. We don't have a post. We haven't defined the post request method. Let's just try defining one thing called at app.post, something like survey. So this is going to have a function survey. We'll define the parameters later based on the fields that we use in the browser. We'll define these. Let's just simply add this here. So I will use a name, one parameter called name. What's the name? Who is the one submitting the form? Let's have some validations here. There is some library called typing library, which allows us to validate these. Even Pydantic uses that. We can directly use that library from typing import and annotated. This allows us to validate. These are all system libraries that each framework will use its own set of libraries. Pydantic is one that is used by FastAPI most of the times. And typing is a default library that comes from Python. We can use that to validate input data. So let's use a validation called annotated of string and the form. So where this form comes from is through the FastAPI. So this form element, when I'm accessing this actually is going to retrieve the form's name element. So whenever I submit something to the post request through a form, all that comes from form element. So basically what this means is, so what this means is get this name object from the form that was submitted to this post API. So when I'm doing the post request through the Swagger API that I've shown, that's actually sending JSON data as the body. So when I'm submitting through a form in HTML, it's actually going to send by default as a form submission element, form element. It's called multi-part data in HTTP post request. That multi-part data will have to be retrieved from this call. So it retrieves that data and it extracts the name parameter from that data and uses in this. So this is a hint to the FastAPI server that I need name to be string, and that has to be extracted from the form that is submitted to this survey endpoint. So name I will retrieve for now and just do a print of name here. Okay, let's go to the form, define the endpoint where we need to send it is the slash survey endpoint, and there should be an end form like this closing tag. Inside this, I'm going to have a simple field, input field. So I'll have a label which has our name, and then I'll add an input field called text. Just like that. And this one I'm going to use for ID. I should use an ID here. ID as name for name. This label belongs to this field is what I'm specifying here. Okay, let's run this in the UI browser and check if it's rendering properly. Instead of hello world, it should render the form. So okay, it's coming. Your name, say, and I don't have a submit button here. Unless I have a submit button, I cannot actually post the request. So I need to add the submit button to the form. Let's add it. I'll create a button called at the end. I'm going to create a button. Right, submit. This is all HTML. We will go over what these elements, each and every element we will do. Discuss about these HTML later. Right now, it's just a sample for demonstration purpose. So now, whenever I click on the submit button, it submits this data to the post request. It will send a post request with the form submission. We will go over that. And let's go to the browser. So before I send it, let's inspect and go to the network tab and then refresh. So I have a submit button. So let's say I'm doing a simple text and then closely observe the post request that goes here. Submit. Detail tag missing. Body name required. Name field required. Okay, basically what this is doing a post request and it's not passing the body because there is no ID called name here. Let's fix that. Here, the name I have specified, ID I have specified, and also I have to specify the name property also in order to make this work. So this name is what the browser will consider for submitting this information. So we are actually specifying the name as name. Let's try now with the new HTML. Refresh. So, so here plus static x. Okay. Oh, I'll submit something here. Okay, now it's passing. So if I see inspect this survey post request, this is actually a post request and response is 200. And payload, if we see, this is going as form data, name as Matish. Let's go to the Fast API. And when I'm submitting this information, let's do the same thing. Inspect and go to the network tab. The difference between form and post request with JSON, I'll show you. If I do a post request here, it's actually sending the post request in the JSON format. Request payload is JSON here. It's passed as JSON. Although it's failing, it's passed as JSON. Whereas here, if you see, it's going as form data. This is called multi-part data. So when I'm submitting information through a form, it's going to submit the data in the form data or multi-part format. It won't go as a JSON string as a body. So for submitting JSON strings, JSON body, we have to make use of JavaScript to Ajax request. What is Ajax request? We'll go over next. But to basically know the difference between form submission and API request through the request payload as a JSON object, this is what it is. So that is why we have used a form element to parse this form data from the request. So request format is different here. If I go over to the code, so the difference between this one, this post request, and this post request is different. The difference is this, we are getting it as an object. So this is through JSON body. If somebody submits a post request through a JSON body or through Ajax syntax, it will come as a JSON object. And if it is JSON object, it will by default convert that into this object that we specified. So when we are handling data submitted from the forms instead of from the API calls to Ajax or through JavaScript, we have to handle the form submissions like this. So what this does is it will extract the data that is passed in the form, and with the name, those things will be passed on to the exact parameters. So the name object, it's going to retrieve and pass it on to that particular parameter. So that's the basic difference between form submitted and the JSON requests. So now let's go implement a full scale interface. Now we are getting a response as null. So but we need to make sure that this goes to a landing page. Once form submission is done, something has to happen. Let's do that now. So I'm going to have a simple change. So after submitting, let's go into the I've logged thing and I haven't returned nothing, but I'm going to redirect to a specific page. Let's say I have thanks page. I want to redirect this user to thank you page. I'll just use redirect response. This also has to be imported from FastAPI. Redirect response accepts two parameters. One is the URL. I'll just use static/thanks.html, but this is not defined yet. I'm going to define that in a bit. And also status code, I have to make sure that this is a success code. HTTP status dot font. So these two things we need to import from FastAPI. Redirect response comes from FastAPI responses. Basically, I'll teach you one simple trick. You don't, the convention is to import all the data, all the imports in the top. And actually, Python allows us to import data whenever we need. I can actually put an import statement here. Import from FastAPI dot response. Import responses. Import redirect response. This is perfectly valid. So usually what we do is we put all this imports in the top because it'll be less confusing. So, but wherever we need, we can actually import those things. And now we also need the HTTP status. HTTP status is a standard class that is defined in the HTTP library, which comes default with Python. From HTTP, import HTTP status. This has to be HTTP status. So that's it. Now I'm printing the name and then saying thank you. Let's have some more information. Instead of just the name, I'll have some extra information. Okay, I still need to implement thank you page. Thanks.html. What this does is it'll redirect the user after submitting, it'll redirect the user to the thanks page. So I have to something here. I'll just put a template HTML again. Just put a thank you here as a title. So this time I'm going to do some small trick with Bootstrap. There is something called Bootstrap library for HTML, CSS, ready-made CSS. I'm just going to use that Bootstrap library. This is the URL to that library. So yes. So this is the link to the library. I'll give you this. I'll post it here. But once I have this, I can define some classes in the HTML, and that will automatically get some styling elements to it. So let's use that. So I'm going to define a container here. Class as container. This is Bootstrap classes. We will go over Bootstrap. This is just a teaser of what's going to be taught in the next upcoming lessons. Container. So this is Bootstrap class. So based on this, it will define some styling, this Bootstrap library. So I'll have one div class row. I'll have another division which classes with the classes column flex. This is display flex. These are all actually CSS rules abstracted away by Bootstrap into classes. So we'll go into the depths of CSS, how to define styling through CSS, plain old CSS, and then wrap them up in libraries. Justify content center. So this class is going to align the text to the center of the page. alert, alert primary. So these are all different ways to represent. This will define the background of the thing. So let's define some thank you here. H1, thanks for submitting the survey. Let's run this from the browser. So static, go to static, index, submit notice, and then now I see this page. This is actually coming because of the styling elements I've added. If you see inspect this, you can see this deep flex alert primary. This background is coming because of the alert primary. So if I go to the CSS rules, so alert primary class has CSS styling. So color as this, and background border color as this, background color as this, link color as this. So likewise, we can actually define these styles ourselves or make use of existing libraries, just like Bootstrap, and add classes to the HTML element so that it will by default get those styling elements. So let's modify this further a little bit and add some more to it. This is how we build user interface, even complex user interfaces. We build it like this with libraries. Let's have another row. If class, so and I'll have another division class column. This means column, call means column. I'll find a paragraph, taking mention 15. One person. Now let's go to index, create some more elements just like these. This time I'm going to add a proper classes so that it looks good. So if you see the difference between, let's capture the difference. Let's go to the static index. I'll take a screenshot of this, or I'll just keep this like this and open another tab. Almost static index. Let's add some more styling to this page also. Let's have, again, this division has to be inside a container. Class container. Inside this, I have row, which has content center, alert, because I'll have 7. I'll have another row. Column. You're taking this again. You have another column now. In this column, I'll have the actual form defined class row, another row, another column. Inside of here, I'm going to have this form entirely copied to this. So this stays same, but inside this, I'm going to have this wrapped up into one more element called form group. Form. Simply speaking, I will add some more elements to it. Form control as a class to it. Class as form control. Some specific styling, and I'll have placeholder as example type your main, and then some more elements I will add. Label for copy, new class, or I'll just say demo. Select. I'll create a select element class as form control. ID as happy and name as happy. So name should match the one that we define. Happy. This element has to come again in the server. If I have to retrieve and see the information, I have to put it here. Annotated. This is going to be a string again. String, and then should be extracted from the form. Let's go over here. Define the options. Option 1 is very happy. Other one, happy. Not satisfactory. Okay. Satisfactory. Now we have 5 options that will be displayed as a form drop down. We will see that in the upcoming. Let's have the button here. Button itself is there already there, but I'll move this button inside of the form. There in the form itself. Okay, that's it. That's about what we need. Happy sorting, and is there anything that we want to retrieve? Talk. Okay, we will have one more added. Let's say I'll have course. Course demo. Okay, now we have this. Let's add this also to the form. Just add this. And I have name happy course. Okay, we're almost done. Okay, now let's go to the browser. Refresh this page. Looks better than this. We have to see, I think we have missed one small thing. We haven't added the bootstrap CSS to this. Here, I think we should add the bootstrap CSS here also. We have added to this, but not to this. Copy and put it over here. Let's refresh the browser now. Refresh. Okay. Now this is what it is. Okay, drop down I'm getting. This I'm getting. I think submit button doesn't have the styling applied. Let's have those classes added to the submit button. I'm going to add class as button and button primary, class as tn primary. That should give us good button. Let's go back to the browser. Refresh. Okay, now it gave a good button here. I'll just add my name, happy. Then, and if I submit, and we got it. And if I go back to the server logs, I would have printed the data. So printed, submitted name, happy course, all this has been printed. So instead of printing, I can actually write it to the database and everything I can do. So that's a simple form build with post request. And we have seen post request with JSON and post request with forms submissions. There are two types of post requests that will come. So with the body as JSON and with the body as form data. So this form data retrieval can happen through this format, not through this format. So if the data comes in JSON format as a post request, then this form will be used. This kind of retrieval mechanism will be used. When I'm getting it from the form submission, I need to use it like this. So that's about the post requests. And next thing is retrieving raw data from the requests and extra information, if not the pagination, all the pagination elements, how to paginate and build more complex JSON responses, how to build and convert an object into a JSON response. All that we will see next. So in our previous class, we have looked into building post requests and get APIs and post APIs with FastAPI. So this time we have seen the post APIs will accept objects like this. This we have seen two different ways to submit information. One is through the JSON, JSON body, which will be passed into this API through this objects format. So we inherited from base model, and from there it works. So another form of submission is through the form data, which we have seen in the survey application. Let me start the server and we'll go from there. Fast API, dev server.py. And we have seen this JSON mechanism of posting data, and then we have created a form, sample form to submit the data, and we kind of refined it to go into a better CSS. So once we have this information submitted, if I inspect it and go to the network tab, see if what requests are going. So there is a survey post request has gone with the payload as form data here. So this accepting this form data is done through similar mechanism that we used for post. When we do post here, the data goes in the JSON format like this. Request payload goes in JSON format. And whereas in the form, if we submit, it's going to go through this mechanism. So different ways to handle that form data has been discussed. Now let's go in depth into how these request objects can be processed. If not form data, if some raw data is coming, if the request object, all the header information and everything, if we need to read and process that information, how do we do that? Is what we will look into today. So for that, we actually need to import request object from FastAPI. So whenever a browser requests post request or a get request, we'll get that in that request format. So let's define a handler and accept FastAPI request object from it. Say example API. So in this, I'm going to accept request as a raw request object. This request object has to be imported from FastAPI. So, but this convention is to put this entire imports at the top of the file, but it works either ways. I'm just going to import it here so that it's near our code. So in this API request, basically I have to assign some endpoint to it. So the way to define it is through the annotations or these decorators. This is going to be a post request. Let's say I will say example raw API. Inside this handler, I'm going to get the header information from the request. Request dot headers. I'll just print these headers on the console. And I'm just going to return these headers itself. Return this headers request headers request dot headers as a JSON object. Let's see how this looks. Let's go to the docs endpoint, I guess, execute. It has sent the headers as a response. What these headers are, it's actually reading from this API request itself. If we closely observe the headers that we passed, request headers, all this information is passed from the browser. So this information, the server is reading that information and sending it back as a response to the API that we are calling. So this time we will do some more operations. Let's say if I want to handle image uploads or handle some errors, let's implement an advanced API that will handle this. So this one I'm going to rename this API, create a new API. Let's say app.post. Let's say I want to upload an image and want to get the size of that image. Let's figure out I should do it. Size as a function. It's going to accept request. It's a hint to the interpreter or the editor that it is a request object that is coming from FastAPI. So I'm going to read the content request. If we see the request object, it will have a field called content length. I will just go back to the browser and show you what I mean. If you see here, so every request will have a content length in it. So what's the data that we are passing? So our entire payload of the request, how much length in bytes, how much size it has. It has 633. Oh, sorry, this is response header, request headers. If you see the content length, how many bytes are we sending in the body? So we are actually not sending anything here, but if we are uploading an image, we will have some data in it. Let's go back and read that request content length, request.headers. And a foolproof way to get the content or any field from the headers is through the get function. We can pass in what field we want to extract from the headers. Content length is what we need. And if it is not there, a default value, I'm giving 0. And this I'm going to store it in the size attribute. I'm going to convert this into an integer. Now we have the size. If there is no, if size equals 0, then I want to raise an exception, raise an error. You have to give non-zero content. You have to upload something to the API. So here I'm going to raise a HTTP exception, which in turn is from the FastAPI itself. HTTP module, HTTP error, FastAPI HTTP exception. So I'm going to use this and send out an error to the browser with the status as this is actually function status code. I have to give it as HTTP status dot bad request. So you haven't uploaded the file. That is why I'm raising an error here. and we can have some details missing content attention. And a simple way to do this is if size equal to 0, or just I can put if not size. If not size actually checks whether size is 0 or not. If the size is 0, it will be false. So that means not or false will become true, and this gets executed. If size is greater than, let's say I want to have a data not more than 5 MB of data, let's define a maximum length for the data that I want to receive. Max means size, say 5 into 1024, 5 MB I'm keeping. So if the size of the request is more than max mean size, then also we want to show that request. Same thing, raise HTTP exception. This time we want to show a different message. Size cannot exceed 5 MB. Now, okay, we have done the validation. Now we have to actually read the data from the request. If somebody uploads an image, yeah, we need to read that data from the request. So that data will come as request.body. So this request body will have the raw content of data, but we want to process this data into an image and find out the length, and let's just get the size of the data. Return size. So how do we now upload the file, send the file to an HTTP request that we have to see now? So if we refresh this doesn't have any idea of how to upload an image. I can actually have some script written to do the upload. Let's try figuring out with this Postman now. I'll just do upload data post request. I'll do the upload with the post request. Let's do one thing here. I will open my Postman. I'm sharing my Postman link. So this time I'm going to use the URL localhost 8000. This time I'm going to use post request localhost 8000 and then size. In the body, I'm going to send raw data. One second. So this binary I'm going to send, some image I'm going to upload from my downloads folder. I'm just sending this. Let's go back to the code. Okay. This data actually does not have length property. Let's fix that. Let me go back to the, okay, we are already in the code. Now let's do something here. Instead of data, we will convert this into bytes IO object. This request data object cannot be directly read into length. Let's create a bytes IO object out of this data. So this bytes IO comes from the IO package from IO import bytes IO. Actually, what this data is a buffer object. We need to convert that into bytes object. So this bytes object can have the length, suppose. Let's run it and see. Still has the same error. Right, select object is what? Okay, let's convert this into an image rather than trying to do. I will just use this IO data and convert that into an image. So for this, I'm going to use a package called image. There is a package called image.io in Python. Let's install that. With install, there is something, the image package name is below for manipulating image objects. Let's install that. I will import that library from here, from PIL. So this below package will give us the PIL library, import image. So this IO object, I'm going to convert this into image of IO. Image dot open, actually, this should be done like this. So this IO is a stream object. So when I converted this data into a stream, so it's an asynchronous way of reading the data from the network. We don't get all the information at once from the request body. So it has to be done through an asynchronous mechanism. So for that, I need to define this as an async. And here, request body, when I'm reading that, I need to make sure that this is waiting on this. That's why we have been getting that error so far. So this time, I'm going to read the data from the request body that I uploaded and convert that into an image. And that image size I'm going to get here. Let's try to get the images width and height. Height has start height. Width I'm going to use here. Let's try now. Send it again. Okay, now it's successful. The bytes object, why it did not give earlier, let's figure out. Let's debug and find out. So this time what we did differently is we have added async and await. So let's remove this also. Yes, I'm going to make sure that I'm reading the size of this data, or else I'll just do type of data. Note that this time I'm not going to use the async function. Okay, I'm using async function. I will remove it and then verify it again one more time. Let's send it, and there is a problem. Object is not iterable. Okay, I think data type. But there is a keyword called type in Python, so it's not allowing me to use that same name. Hmm. Object is not iterable. Again, the same issue. I'm just going to use type of data. Yes. Send the request one more time. Let's see the response. It's the type of the data. This is a bytes object. Okay. Bytes object, we should convert that into, okay, if I don't use await, let's see what's the object. It's a coroutine. Okay. So this request body function has returned an asynchronous promise. It's a promise. Coroutine is in Python is in JavaScript we call it as a promise, and in Python we call it as coroutine. So it's actually asynchronous handler. So we have to wait for the asynchronous coroutine to complete before proceeding with the next operations. So let's do await. So that's why we were not getting on a promised object. We were not getting the actual data. So whenever I'm using await, I still need to use async in the handler function definition. So this data is actually raw bytes of data that is coming from the request. So we can read it into an IO buffer and then read it into the image. And there is a way to convert bytes IO object into a string. We can convert that into a string also, but this time it's not going to work because it's an image object, which is a binary. We cannot convert that into string. So this is how we read raw request from the post data, raw request body from the post data. Not only the form data and JSON data, we have seen now how to read JSON data like this through the post request, how to read form data that is submitted from the browser. And apart from that, we also have the ability to read the raw request headers and also the raw request body. A binary also we can read from the request. So any request that we send, we can either send it in application JSON format or the form data format or any kind of binary format. So all three types of requests can be handled in this way. So we have seen three types. So the same set of operations can be done on put requests and patch requests. So instead of post request here, if I just declare it as put request, it's going to use put. So rest of the things all remain same. It's just the mechanism, which type of verb we can use. It's only a convention rather than a rule to follow these post, put, delete operations. You can do delete operation on a get request also. It's up to the implementation what we do in the server code rather than sticking to the verb that we use. But REST API definition allows us to use post request for create and put request for update. So most of the times we will be using post requests only for most of the update operations also. So that's how we build APIs. Now let's go a little bit into practical implementation of how these things can be applied to a practical use case. Let's say I have a data center or a server which I can start with the APIs. Let's create a new API. It's just going to wrap up all the things that we learned so far into one single API server. So this time I'm going to use enums. Enums is a feature in Python which we haven't looked into yet. So let's use that from enum. Import enum. So enumeration, enum nothing but is an enumeration. Enumeration means it's a collection of predefined data strings. Let's create a class called image that inherits from an enum. So this is a server image, let's say, or I can say OS image. Let's say Ubuntu. I will define Ubuntu as an OS image, which has a string Ubuntu 24.04. I'll use another one, Debian. Bookworm. I'll explain what this enum is and how this works. Alpine 3.20. What this OS image is, it's a enumeration. So enum is also a class in Python So enums allow us to have predefined set of values to this object. Let's say mm, in an application, let's say we want to allow only a specific set of values to a particular entry. That time we will have to use enums so that we will predefine those values and not allow any other types. It's also a string. A predefined set of strings only is allowed for that field. So in those scenarios, we will use enums. I'll use this enum and then it'll be evident how to use those. Let's create a class called VM that has base model. So it's an object. We are going to receive a request through the VM object from any post request. I'm just giving a name to this. So it's a virtual machine. Let's say this is kind of a so what I'm going to write here is the service will start the virtual machines on a remote data center. That is what we are trying to write, a practical application of this. So a client will request for a virtual machine from the data center, giving the image name. So what's the image name I want to bring up my virtual machine in? So what is the virtual machine and all? We can discuss later. So I need a virtual machine with a CPU count as some number. It's an integer. We have already seen that all API requests in every object that we use will have field as an initializer. So what's the validation that we want to use? Greater than 0 and less than 65. Memory size in MB or in GB. That is also an integer. Field greater than 8 GB. Basically greater than or equal to I can use. And it should be less than something like 1025. These are the parameters that are going to come from the post request. And then image, I'm going to use as OS image. So what this makes sure is that it doesn't allow any other string other than these three strings. Either Ubuntu, Debian, or Alpine. Any of these three are only allowed. If any other thing is passed, it will throw a validation error for us. So this time I'm going to add one more. Now we have defined the data structure that we will receive from the post request, and now I have to write the data post request itself, post request handler. So this time I'm going to use VM start, define a function start VM with the base model VM virtual machine. So I'm going to use a unique identifier UID4. There is a library called UID4. We haven't installed it. I will import some UUID. Yeah, this will give a unique string. Let's visit that and see how that works. I can import from UUID, import UUID4. And we have to install VM pip install. from UID import UID 4. So what this UID will generate is a long string of data. That's a unique, universally unique ID. So in large databases, large data applications, big data applications, we use this UIDs extensively. So for that VM, I'm going to assign a specific ID with the UUID. Now I'm going to start that VM with VMs of ID. Let's define a data structure here. VMs as a dictionary. That's it. Now I'm going to return this ID to as a response. Let's try running this now. Let's go to the browser. So if you see here, it allows only the values that are defined in the enum. Let's just try giving something like 25. Let's see if the server allows it. Start, and the server has automatically given a response. Unprocessable content. Let's try what's the error. Let's figure out. Let's stop and start the server again. Let's use a valid number first and see if things are working. Then we will try to break things. Okay. So it was successful, and let's try 25.04, which is not defined in the enumeration. And it threw an error, unprocessable content. And response, and if you see the response, the same response is here, error, unprocessable content. Expected one of these three. Input should be one of these three, and input has been given as 25.04. That's the advantage of using enumerations. So even if somebody sends wrong information, we will automatically have this evaluation done by the server if you use enumerations. Okay, so we have seen that. Now let's go to serializing a specific data format. Let's say if I have one object, how do I serialize that? So by default, objects can be serialized if the object has properties, all default properties, data types as integers, floats, or default basic data types of Python. All of them can be serializable. If some object doesn't have that, how do we do that? Dumping of serialization, we will see next. And there is some kind of advanced concept called streaming the responses, which I don't think you need it right now. Once we look into the implementation of UI to current APIs, so 99% of the times you will be using the API mechanism only. So streaming data will not be required. So that's why I'm going to postpone the discussion for further time. Streaming responses need not be done right now. And I think we have mostly covered the basics of REST APIs in Fast API. I think we should look into Django, and then we will have to implement a UI on top of Django with the HTML basic JavaScript.